If you've ever sat in a meeting where, someone was asking, should we use a data warehouse or should we use a data lake? You've probably sat in another meeting a couple months later where the answer turned out to be, well, both, kind of. And also, like, we need to talk about this thing called a data lakehouse now, also. What I'm going to be doing is trying to clear up what those things actually are, what they're good at, and why most companies end up using both. And really try to help you figure out how to think about which one you should be reaching for when. Now, those terms get thrown around so loosely that honestly, I do think we need to ground them before we move forward. So, a data warehouse is a database optimized for analytical queries. Like the kind where you scan over millions of rows to compute totals, averages, trends, and like other things that like a business analyst would care about. It's like it almost always uses a structured like relational model. You define the schemas, you load data into tables, and then you query it with SQL. So like good examples, modern examples are like Snowflake or BigQuery or Redshift. And then like if you're like older ones, like Teradata is a good older one. Anyway, the defining feature is that the data has been cleaned, organized, and shaped before it lands. Specifically, the reason for doing that is so that way queries run fast. A data lake, on the other hand, is a centralized repository where you dump files in whatever format they happen to come in. So JSON, CSV, log files, images, videos, sensor readings, whatever, anything. We're dumping it in there. There is no enforced schema, no required structure, no SQL engine baked in. The lake is just storage, usually backed by some kind of object store like S3 or like a blob. And the defining feature is that you can put almost anything in there cheaply and then figure out what to do with it later. And to be clear, these two are not competing products. They're just different shapes for different jobs. So a warehouse, you kind of think of it like a kitchen, right? It has a prep station. It has like a knife rack, a sous chef, who's already like chopping up the onions for you. Whereas a lake is more like a walk-in fridge, full of ingredients. And then you just take what you need when you need it. Okay? Both of them are useful. They're just useful for different reasons and useful in different situations. Now, warehouses are built for one thing above everything else, and that's making analytical queries fast on structured data. So if you're a business analyst and you want to know the quarterly revenue by region broken out by product line with a year-over-year comparison, and then maybe you want that back under 3 seconds. Well, a warehouse is the right tool for you because the data is already in tables, the columns are typed, the query planner knows how to scan billions of rows efficiently because the storage format was designed for exactly this kind of a job. The other thing that warehouses are good at is being approachable, right? I mean, SQL is pretty well known. Most business analysts already know SQL. BI tools like Power BI or Looker are able to plug into warehouses with almost no friction. It's relatively easy to do. If your goal is to like put a dashboard in front of, an executive who wants to see, a chart go up, well, a warehouse plus a BI tool is a very short path for you to get from that idea to a chart. The other thing is that warehouses also enforce structure, which may sound restrictive. However, if you've ever spent any amount of time trying to reconcile two slightly different versions of the same field across like 40 different CSV files, you will know that that is a blessing in disguise, right? A schema is a contract. It says that this column is a date, this column is a dollar amount, this column is going to be the customer's ID. And if you try to put in anything else in here, I'm going to reject it at the door, right? The contract is what makes the data trustworthy enough for you to base a quarterly board report on it. The catch, though, because there always is one, is that getting data into the warehouse in the right shape is not free. It requires a ETL process, right? You need to be able to extract it from the source, transform it into the warehouse schema, and then load it into the tables. And I mean, ETL is where a meaningful percentage of every data team's time goes, right? And it's the part that no one puts on the slide because it's not glamorous and it's full of edge cases. So I remember one weekend where I was like I don't know who did it. I think it was the person who had, I don't know, like we had a 2-person team and someone before me had written some put together some transformation logic, and I was sitting there trying to like reverse engineer it to figure out why the numbers on the dashboard looked weird, and it just anyway. So unglamorous. You don't tell people about that. Not the executives, at least. Data. Uh-oh. Data lakes also solve a problem that warehouses are bad at, right? And that is storing data whose shape you don't know yet, or whose shape changes too often for you to really bother defining a schema for it, or maybe its shape isn't tabular at all, right? So like, say you have some data scientist and they want to train a model on 5 years of customer support transcripts. Well, those transcripts are text files, but they don't fit neatly into rows and columns, right? And trying to force them into a warehouse table would either require you to throw away most of the structure or invent some other kind of structure that nobody else will really ever be able to use. So the easiest call is to drop them into a lake as a folder of files. It just makes more sense. And then the data scientist can like read it with like a Python library and then process them however they want and produce whatever output the model needs. Lakes are also dramatically cheaper than warehouses for raw storage. Like object stores like S3 cost pennies per month, whereas a warehouse might charge 10 to maybe 100 times more for the same amount of storage, because you are also paying for the query engine and the indexes and the compute that makes those queries fast. And if you have terabytes of data that you might want to look at later, but probably will not query every day, putting it in a warehouse is like renting an apartment just to put all of your old college textbooks in there. It's like technically possible, but it's wildly inefficient, okay? The other thing that lakes give you is flexibility. Because there is no enforced schema, you can ingest data from a new source today if you wanted to, and then you can decide what to do with it next week. You can store data from the same data set in 3 different formats for 3 different customers. You can keep the raw untouched version of the data alongside the processed version, which can be incredibly useful for the day someone asks, hey, is that number right? How do you know if that number is right? Well, you can go back to the source because you have it right there. This is something we call the sushi principle. That's sometimes called the sushi principle, which is the phrase, which is a phrase someone in data, I don't know, someone in the data world coined it. And I'll quote it here today because why not? Even though it sounds like I made it up, right? The point is that raw data is better. Keeping the original is a feature, right? Because every transformation you apply is a place where a bug could potentially be hiding, and being able to reprocess the same source is really the only reliable way to fix them in a lot of cases. Now for the unflattering parts. Warehouses are bad at unstructured data, right? They're bad at workloads that do not look like SQL. They're bad at storage costs. When you have a lot of data that you rarely query. They're bad at handling rapidly changing schemas without a lot of ETL pain. And while there are some modern cloud warehouses that have like made huge strides on like price per query, they are still pretty expensive for like if your goal is to do like exploratory work where you don't know exactly what you're looking for, and you might need to like run 100 bad queries before you find a good one. Yeah, that it could be potentially really expensive. Now lakes are bad at being usable. Yeah, they're bad at being usable. A data lake at its heart is just a folder full of files. And folders full of files have a tendency to become folders full of mysterious files where no one remembers their origins. And without like rules in place and like a clear structure in place, structure is the wrong word there. Without rules in place, let's just do that. A lake can very quickly turn into what people call a data swamp, where it's just terabytes and terabytes of stuff. No documentation, no schema, no idea what's current, what's stable, and like just like a faint sense of dread whenever anyone asks where a particular data set lives, because you're like, oh god, I have to go find that now. Lakes, they're also bad at fast queries on their own. So like a raw lake is just storage. To actually run an analytical queries on the data inside of it, you need a separate compute engine like DuckDB or Athena or Spark or Presto, whatever, something. And that engine then has to crawl the files and parse it and execute the queries. And without indexes, statistics, or careful file layout, this can be like slower, much slower than a warehouse for this same exact query. And then, the compute engine has its own thing to operate, which, adds complexity that a managed warehouse would hide from you. So where warehouses are fast and they are structured, are fast and structured, but, expensive and rigid. Lakes are cheap and flexible, but slow and chaotic. You can probably see where this is going. The answer is almost never warehouse or lake. It's how do we get these two things to fit together in a way that isn't going to drive everybody insane? The most common pattern looks something like this. Operational systems, like the database behind the products, whatever the SaaS tools that the business is using, all of that feeds into a data lake first. The lake holds the raw data in whatever format that it arrived in with like very little processing. And then this will act as the source of truth for analytics. So if a number is ever in dispute, you can go back to the lake and verify that number. And then from the lake, a subset of the data, like the part that an analyst or whoever or a dashboard actually needs, is going to get transformed and loaded into a warehouse. This is like, that's going to be like the cleaned, queried, optimized, structured version of things. And this is what the BI tool is going to connect to. It's like it's what the executive dashboards run on. It's going to be much smaller than the lake because it only contains the data that has been deemed worth the cost of warehousing. Like data scientists and machine learning engineers, they tend to primarily work out of the lake because they need access to the raw unstructured data, and then they tend to build their own pipelines anyway. Whereas a business analyst is most likely going to primarily work out of the warehouse because they need fast, reliable, schema-enforced data, so that way they can write SQL rather than like Python, like a data scientist or machine learning engineer might. But with this structure, both groups are happy. Both groups get to use the right tools for their job. And then the data team gets to spend their time working on the plumbing between the two, right? Which is like the job. Now, this pattern does have like a few variations, like common variations. Like sometimes the warehouse comes first and then the lake gets added later when someone realizes like, hey, the warehouse is too expensive for raw storage. Sometimes the lake comes first and the warehouse gets added when someone like asks for a dashboard, or like and like maybe something like Spark is too slow. Sometimes the two things kind of merge into a single system. We'll talk more about that. But the underlying division of labor is remarkably consistent, right? Cheap raw storage in one place and then faster structured queries in another. Now, around 2020, vendors started using the word lakehouse to describe systems that try to give you the best of both worlds. They try to give you like the cheap, flexible storage of a lakehouse combined with the structure and query speed of a warehouse. Databricks probably coined the term most aggressively, but like Snowflake and Google and a bunch of others have their own take on the same idea. And what the technology underneath usually involves is storing data in some kind of open columnar format like Parakeet, organized using a table format, some table format. And what these table formats do is they add things like schema and transactions and efficient updates on top of the plain files in object storage. And the result is something that kind of looks like a warehouse, kind of looks like a lake, kind of acts like both. I mean, what you have to remember, though, is that as cool as this idea sounds, it's not magic. You know, for some workloads, it's really a great fit. I mean, the idea alone of not having to move data between two systems is very appealing. But like everything, lakehouses have trade-offs, right? They tend to be slower than purpose-built warehouses for query warehouses. They tend to be, if I said that properly. And they also tend to be slightly more constrained than lakes for unstructured stuff that lakes are best at. They kind of sit somewhere in the middle. And you know what? This is great for a lot of teams because this is exactly where a lot of teams want to be. But it's very wrong for teams who want to be at either extreme, right? So I would say if you are starting fresh and your workload is not at either extreme, then a lakehouse architecture might be worth considering. But if you already have a warehouse and a lake that work well together, the benefits of migrating might not be worth the time, effort, and cost. It just really depends on your particular case. All right, so here are a rough set of questions that we can work through when someone asks where to start. first we would ask like, hey, how big is your data and how fast is it growing? If you're at gigabytes, neither a lake or a warehouse is strictly necessary, right? Postgres on a decent machine will probably serve you fine for a good long time, you know? If you're at terabytes, you probably want one or both. If you're at petabytes, you're almost certainly going to need both. And you're going to need to spend real money no matter what. Another thing you want to ask is, hey, what does the data actually look like? If almost everything you have is structured, clean rows from operational databases like transactional records, well-formatted events, a warehouse alone might just cover it. But if you have a meaningful amount of data that's unstructured, logs, images, artifacts, models, whatever, you'll probably need a lake at the minimum, and then probably a warehouse on top of that for the structured slice. Another thing is the audience. Who's going to use it? If your primary users are business analysts who want dashboards and SQL, well, then you need a warehouse. If your primary users are data scientists who are trying to train models and who need to be able to explore raw data using Python or R, well, then you need a lake. And if you have both groups, you need to do both. And you also need to determine, which one's the source of truth in that case. Next question is, how much operational capacity does your team have? Warehouses, especially the modern managed ones, are relatively turnkey. Lakes require glue, honestly. Like you have to pick a query engine. You have to manage like file layouts, handle schemas, deal with like the swamp problem, hopefully avoid the swamp problem. And if your team is small or stretched, it might be wise to lean warehouse first and then add the lake later. That may give you the least amount of pain in the end. And then the last question is, how much do you care about cost at scale? Right? If your data set is large and most of it is rarely queried, the lake will save you a lot of money compared to warehousing everything. But if your data set is small and constantly queried, the warehouse cost is fine, right? And the lake is probably going to be overkill for you.